Hi, this video covers texture baking in Houdini. I'll talk about your options when baking from high-resolution sculpt to the waves mesh, and I'll also demonstrate how to bake your procedural shaders done in Mantra into texture maps that you can use with any render. One reason why you might want to do baking in Houdini is that compared to other applications available today, it offers slightly more flexible workflows, in my opinion, in terms of geometry and UV manipulation. So I'm starting out with this big head base mesh and then this quick sculpt I've done in Blender. As the first example, I'm gonna bake this sculpt into displacement and normal textures. If I jump inside of these, you can see no more than just a plain geometry, so nothing special here. The first step to be able to bake anything, you go to the out context and drop down a bake texture node. This node basically is mantra node with a preset specific to texture baking. It has some obvious controls here. A camera must exist in the scene, but it doesn't have to be set in any specific way. Then by default it's set to bake UDIMs, which can be changed to PTEX if you wish. The resolution by default is 1K, which I think is sufficient for this example, but I don't think it's limited in any way. With really high resolutions though, it tends to sort of choke on memory, so I recommend doing maybe 4K textures distributed over more tiles. Down here you pick the render objects. The UV object is your base mesh, so I'm just gonna select that. And the high-res object is your sculpt. There is an option for a UV cage object, which is basically a base mesh offset a little to indicate the baking direction. This may be useful maybe in some cases, but I personally never ended up using it. And then output picture is where your textures are gonna go. So I'm just gonna put it into the textures folder and leave the button like this. I'm gonna render in Mantra, so RAD file is perfectly fine. Otherwise, you can bake into EXRs or whatever suits you best. For now, I'll just check this tangent space normal and displacement. So this is gonna be my two outputs, and I'm gonna bake them into RADs again. And I wanna remove intermediate output, which is something you want to keep if you baking also the lighting information. Here in output tab, this is like your naming convention. So displacement maps, it's going to be called DS, and normal map is going to be called NT. You can type anything you want here. So if you want to name it differently, it's your choice. Now in baking, you don't really need to change anything here at this point. But on the unwrapping tab, there are some important settings. If you click this drop-down menu, you can see three options to choose from. And each of them is like a different way of projecting the high-res mesh onto UV object. In this particular case, I'm gonna pick the UV match, which is technically the most accurate method, but it requires the two meshes to have matching UVs. The other two are sort of raycasting solutions where Houdini is trying to match the objects based on similarity of its shapes. Typically, these provide like good enough results as well, but UV match is always the most accurate. You don't need to change any of these. And UDIM post-process, by default, it's set to diffuse fill, which sort of bleeds out the color from UV shells into the empty space around them to prevent visible seams in render. But I sort of like this border expansion better, which sort of just expands UV shells a little bit. And this option here is how many pixels it's gonna do. In render tab, at this moment you don't have to change anything. And in advanced tab, this actually allows you to select objects you want to render. So if I right now just click render, it will error out. and it says no match for object one, blah blah blah. The reason for that is that you've got a star in candidate objects, but at this point my base mesh is like not visible. It doesn't have a display flag on, and that's the problem actually. So what I do is that I just delete this and drag and drop this to force objects. This is like a relative reference to whatever is here. So if you change this, it will change here as well. And you do the same thing for this guy. So if it's in force objects, it means it's going to be rendered regardless of its display flag. So if I render it to disk now, I should see the result shortly. And here we go. So this is a normal map, and this is displacement. So let's try test render now. First, create a mantra node, and actually, let's go to OBJ network, and I'm gonna create another geometry. Create an out node here, and I'll what I'm gonna do is I'll call this big head render, and I'm gonna object merge my base mesh. So right, and go to material context and just create default principled shader and drag and drop on your pig. And here in displacement, I can enable texture. I have to change the offset to 0 because 0 is the neutral value in my displacement texture. If you had scan surface or ZBrush export, it's typically normalized between 0 to 1, but in this case the range is from -1 to 1, and FX scale is going to be 1. You can immediately see something's happening here. It seems to have like a wrong direction, and so I'll just invert the effect like this, and I'm gonna load my normal map as well. This is gonna be again -1 to 1, and that's pretty much it. You can see in viewport right away that it's doing something. Let's see how it looks rendered from Mantra. So I'll go to objects, and force object is going to be my render object, and yeah, I think that's about it about the settings. Go to render view and just render the guy out. We've got something, but you can immediately see that it doesn't look quite right, and we have some like nasty artifacting here. Why this is happening is like this is actually these are actually polygons. So if you go to your scene view and activate your polygons, so these polygons are actually what you are seeing in the render. See, so this is one important thing to know, that when baking out a sculpt onto a low poly mesh, your base mesh has to have this render polygons subdivision enabled. And now, if I bake the textures again, it should be all good. If you overwrite any texture files, it's a good idea to go to render menu and select this update textures option. It basically forces Houdini to flush the cache and reload any textures on demand. So I'll do that. And if I render again, yeah, artifacts are gone. So this is good. And the remaining things you can see here, like the sharp edges, are actually uh, because there is not enough resolution in your base mesh. So you can fix this by adding normal node and like smoothing those normals. Just create a camera. It's gonna be easier to see what's going on. And you can render as a subdivision as well. It's gonna help you smooth out some remaining issues. Let me turn off these lights, and yeah, this is better. All right, so that was easy. And another example I wanted to share with you is the case when you don't have the same UVs on your sculpt and base mesh. This is typically a bit problematic situation if you do sculpt and then you decide to change UVs or manipulate the base mesh topology. But in reality, as you keep working on stuff, you frequently need to do some adjustments in later stages, and then the whole thing becomes kind of a mess. Fortunately, in Houdini, it's not such a big deal, so let me demonstrate how you go about that kind of situation. First, I'm gonna generate new UVs on my base mesh. I'm just gonna use UV unwrap real quick. Okay, so this is my new UVs that I want to bake into, and my sculpt still has the original UVs, or it doesn't have to have UVs at all. So right now, if you bake with this unwrap method to set to UV match, it's just gonna break. It's not gonna work. What you can do is to choose UV to surface or trace closest surface options. These two are like different methods. UV to surface relies on base mesh geometry normal to find a baking point on the high-res geometry, while trace closest is looking for the closest location on the surface, which doesn't have to necessarily generate the same results. The issue with UV to surface is, since it's normal based, that it can only sample in one direction away from the surface. So if it's going through each other like this, it will generate artifacts. For you to be able to successfully use this method, you would have to either shrink or inflate your mesh so it's entirely inside or outside of the sculpt. Minus 0.01 seems to be a good value. The thing is, if you've got sort of more complicated mesh, it can easily create unwanted topology, polygons crashing through each other, and things like that. Definitely want to avoid, because all these areas are going to be problematic. But right now, if you render that with unwrap method set to UV to surface and render to mplay, you should see fairly similar results to what we had before. You can see that we have new UV layout. That's right, but it's all messed up. So this is not great. And what you have to do in this case is to reverse normals. So if you do this and render to mplay again, it should look much better. Okay, this is looking much better. And you've just baked your high-res sculpt on new UVs. So you can see some artifacts here. This is probably some thin parts of a geometry or like These are probably interpenetrating or something. So it's generating some artifacts, but it's not too bad. It's definitely usable. However, in this case, I'm going to use trace closest surface. What this is doing is it's actually trying to find the closest location on the high-res surface, and that's actually the baking point. The good thing about this method is that it doesn't rely on geometry normals, so you don't have to manipulate your base mesh. So it's up to you trying out which method works best for your particular situation. Now let me try to render it out. So I'll snapshot this. This is our original render with UV match, and now I render with new UVs. As you can see, it's not the same. So let's go to the material, and here I change my displacement FX scale to 1, and now it looks good. Now it looks correct. And if I swap these, you can see it's really close. Actually, trace closest surface looks even better now because this little artifact has been fixed. This little weirdness has been fixed. So you can see like it's slightly shifted. It's not absolutely the same, but it's really close, and I think the result is really good. So this is what you can do if your sculpt and base mesh doesn't have the same UVs, or the sculpt doesn't have any UVs at all. As the next example, I'll show how to bake shader into UVs. So I'm starting out with the same big head, and this time I've put this silly hat on top of it. And if I go inside the geometry, these nodes are just generating some attributes that will help me to drive the shading. And I can visualize that: curvature, occlusion, thickness, and a couple of masks. And this second branch, that's actually what's going to be baked. I use this exploded view to separate different parts of the mesh for a reason. I will disable it for now, and then I'll explain why did I do this later. So this text bake is actually a geometry that's going to be linked to a texture bake node, and all that's inside is just this object merge that's pointing to this node here. Both of these have a material assigned. If I go there, it's this guy, and this is actually some procedural stuff I did. I'm not gonna explain all that. Only thing that's interesting are these red nodes, and these are outputs that are gonna be baked into individual layers. So the resulting files will be like a color texture, roughness, normal, and displacement texture. Actually, all these should be color, not float. Just one more note before moving on. If you're planning to bake lighting as well, alongside with other textures, your shader has to be wired in like this into the CF connector of the shader output node. The reason for that is that Texture Baker operates in ray trace mode instead of otherwise more common PVR. And for that, CF parameter is recognized as a shader output. So to bake this shader, I'll go to the out context and create a new bake texture node. And this time I'll call it shader. And the main difference from previous case is that this time we don't have any high-res object. We only are baking our UV object and its shader. So I'm gonna select that. And I'm not gonna choose any of these because this applies only when you have your high-res object present. Instead, I wanna make a list of shader outputs that I want to render. So you have to add your extra image planes, and the vex variable is a corresponding name with whatever you have in the shader. So I'm gonna pin this and go to material, and like names of these red ones have to go to this vex variable. So this is called color. So just gonna type color, and then we have rough, normal, and displays. So these are our layers, and then just copy this and put it in force objects as before, and that's basically it. If you render to mplay now, you should see the result. And here we go, we have our layers, color, roughness, normal, and displays. And as you can notice, it started immediately rendering another frame, which is like a second UDIM. In my model, I have the pig head on the first tile and the head on a second tile. So it automatically renders as many UDIMs you have. Now, here you can notice some artifacting, and this is actually caused by objects interpenetrating each other in a result that makes Texture Baker a little bit confused because it doesn't know what color or what surface you want to bake at that particular point. So if you check the model, you can see that there is some interpenetration going on, like at this spot, and like I guess here as well. So to fix that, I go back to object level, go here, and that's actually a reason why I dropped that exploded view node here. What this is doing is just moving the different parts of the geometry away from each other. So that helps preventing this interpenetration issues. If I render now, you should see all the artifacts down. And see, now it's clean. So that fixed the issue. Now, if you just want to patch something like I did with this head here, you don't have to render the whole thing. You can do that simply by deleting what you don't want. So if I go to my exploded view and select the head and delete that, delete non-selected, and render it now, it should only give me the hat. See, now it's rendering just the hat straight away. As I mentioned earlier, if you're rendering really high resolutions, so let's try 4K. It can get kind of slow, render to mplay, and we'll see how long it takes. So this frame here took like almost 10 minutes to complete. Fortunately, there are a couple of things you can do to speed things up, so let's try it. So first thing you can do is to go to rendering parameters and render properties, and in filter type bucket, and add this tile size to your list of parameters. And if you apply and accept, you can find it here. By default, it's 16, and when the image was rendering, you could notice how tiny these buckets were. So if you aren't baking any complicated lighting, you can go really high with this one. So if you go to 128, that alone should help render the image faster than before. So let's try that. So as you can see, this frame with adjusted settings took only 7.5 minutes instead of 9.5, which is a little bit faster. And if you rendered to like even higher resolution, like 8K, the difference would be even higher. Having said that, increasing the bucket size doesn't always make your rendering faster. with very complex shaders or super heavy geometry, it can like actually slow it down. So it's up to your trying out and consideration what works best in your particular case. Second thing you can do is to actually disable displace rendering. So what this is doing is that it disables geometry subdivision in render time. So if you did a regular render, it would be missing a displacement. But since you are just making texture layers, you don't really need that. And the third thing is sample data cache size. Now, with this simple model, it doesn't probably make any difference. But if you're rendering heavy meshes with a lot of textures and like a lot of everything, you want to bump this up to say like 496. This is actually the amount of memory Mantra is allowed to use for its internal computations. And this can make a big difference actually. Another thing you might want to do is to bake not only texture layers, but also the lighting information. The shader with the lighting baked into it would appear here in this C image plane here. But right now you can see it's all white. The reason for that is when you go to baking tab, you can see this disable lighting and emission option on. That's sort of an optimization feature that omits all the lights and shading and just renders flat texture layers. And the resulting render is much faster in case you don't need any lighting. If you turn it off, you will see the resulting color together with the lighting information baked into the texture. Now, if you zoom in, you can see quite a bit of a noise, and that's caused by insufficient sampling. So if you go to rendering tab, you can bump up these pixel samples and maybe also ray samples. This is the same as what you can see in a regular Mantra node. So just bump up your sampling, and if you render again, you should see improved result. So if you compare, it's obvious that this is much smoother. The noise is almost gone. So right now, if I want to see the result, I'm going to create a new geometry and call it result. And inside there, I'm just gonna object merge the pig. And I'm gonna create a new material for that. I'm gonna call it result as well. And just drag and drop. Actually, before moving on, let me go back and clear all these attributes because I don't need them anymore. So let's drop a clean node and remove everything except of UVs. So I end up with a cleaned up model with just position and UVs. Now move back to your material and make this one, and just start populating it with your textures. So I'm gonna choose the color. Since we have UDIMs, I need to use this little expression. And as you can see, it immediately pops up in the viewport, and you can start populating the other slots with textures. So this is roughness. and I'll use subsurface scattering, and that's the same texture as base color, so just copy parameter and paste it there. This is something that's not going to show up in viewport, but it will affect the rendering, I mean ray tracing. And then for normal map, select that. In our case, we baked our normal map in -1 to 1 range, so change it to that. And finally, load our displacement map. Oops, displace, make it readims, and offset is 0 because we have a neutral point in 0, and FX scale is 1. So it's a subtle effect, but it's doing the job. So as you can see already in viewport, it looks pretty good. Now let's try to render it out. So in Mantra here, change this for the result and render. As you can see, the result is identical with the original shader. Thanks for watching, and see you next time.